to volunteer to read this question A for us. Who want to read? Mark?
Do you want me to read the whole thing?
Just this question, A.
Starting at A?
Yeah, here.
I will find the volume of the solid obtained by rotating the region bounded by the given curves about the specific line. Sketch the region of the solid in a typical disk or washer. X equals 2 squared root of y. X equals 0. Y equals 9. About the y-axis.
Okay, very good. Thank you so much. And I told you, okay, I'll only let you, solid region rotate about x-axis or y-axis. We're not doing any other lines, okay? We're not rotating about x equals 1 or y equals 2. We don't do that, okay? Only about the axis, okay? Now let's look at this question. What is a boundary region? How can we draw x equals 2 times square root of y? X equals 2 times square root of y. How to sketch the graph of it? X is a function of y. This is x, this is y. Remember, y equals square root of x. How can we do y equals square root of x? Looks like this, right? Now, x equals twice of square root of y. So our graph should look like this, right? Well, if you don't know how the shape of it, we can always use key points. When x equals 0, what is y? Well, when y equals 0, what is x value? 0. When y equals 1, what is x? 2. So when x equals 1, when y equals 1, y equals 2. So I would say, when y equals 4, 2, 3, and 4. When y equals 4, what is x? When y equals 4, x should equals what? 4, right? Because square root of 4 is 2, 2 times 2 is 4. Okay, and you can try key points. So, x equals 2 times square root of y briefly looks like this, okay? It's bounded by this curve, and when x equals 0, what is a line what is a line for x equals 0? X equals 0 give us what? Y-axis, right? This is the y-axis. And y equals 9. Y equals 9, horizontal line or vertical line? Horizontal line passed through when y equals what? 9. Okay, so do you see the boundary region? Y-axis, x equals, this is x equals 2 times square root of y, and then when y equals 9, it is horizontal line. So what is the boundary region? This, right? You guys what's good? It's just looking very similar to the one that, we just saw from the textbook, right? Alright, rotate this thing about y-axis. What can we get? A ball, right? Rotate this, thing about the y-axis. That will give us a ball as our solid. Right? Now, how to find the volume of this ball? we're going to use our formula, right? Volume equals from C to D, A of y dy. What are the C and the D? This ball, vertically, it varies between when y equals 0 all the way when y equals what? 9, right? 9. So volume y, v equals 0 to 9, dy this time, okay? dy. Now how to find the a of y? Where's a of y? What do we do this time? See? We're going to cut this ball horizontally and pass through when y equals what? Y, right? So see, for example, I'm saying, oh, so y is here, okay? This is y-axis, I put it on top, okay? So if y is here, and I'm going to use a knife to cut it, and then, can you imagine what kind of cross-section we can get? What is it? We should get a disc, right? We should get a disc, okay? So for that disc, what is the radius of the disc? When y, okay, so what is the coordinate of this point? We want to know the length of the radius, right? What is coordinate of this point? This point. When y equals y, x equals what? 2 times square root of the y, right? So for the radius this time, we are going to check from when x equals 0 to x equals here, right? So what is the radius of this disk? I say it is what? 2 times by what? Square root of y. This is hard. When y equals y, x equals 2 times square root of y, and then the radius, okay, we look at it in the x direction, parallel to the x direction, right? So this point has coordinate y, 2 times square root of y, so the radius is what? 2 times square root of y, okay? So area of y should equal what? Pi times by 2 times square root of y square. You guys agree with this? Okay. And let's simplify. Pi times by 2 times square root of y squared give us what? 4y, right? So actually this is what? 4 pi y, right? So this is a of y. Now I'm going to plug in a of y here, okay? So we have a 4 pi as a constant. 4 pi times by 0 to 9 y dy. And then let's compute the antiderivative. 4 pi is 4 pi. What is the antiderivative for y? 1/2 y squared, right? And then evaluate from what? 0 to 9, right? And that gives us the 4 pi times by 1/2 times by 9 squared minus 1/2 times by what? 0 squared. So eventually, tell me your answer, please. What do you get? 4 pi, this is 81 over 2, right? So 4 pi times 81 over 2, is 2. So what do you get? Do you get 162 pi?
No.
Yes. Okay. See, this is a disk case, okay? Yeah, it's a disk, okay? Can we move on to the next question? Okay, our next question is find the volume of a region, bounded region. It is y squared equals x, x equals to y. So actually it should be read as x equals y squared, okay? Because now we're talking about x is a function of y, right? Yep, we can write it like this, but we write it as x equals y squared, x equals 2y, makes more sense, okay? Looks better. rotate this bounded region about the y-axis. So let's see what we can get. So let's draw the picture for these two curves. X equals y squared. How to graph x equals y squared? We know y equals x squared give us what? Parabola looks like this, right? Y equals x squared. Now how about x equals y squared? Can you imagine? It's going to be looks like this, right? And then let's use key points. When y equals 0, x equals 0. When y equals 1, x equals 1. When y equals 2, x equals 4. Right, guys? And then this is a curve. What is the other curve or line? X equals to y. How to draw that? Key points. When y equals 0, x equals what? 0. When y equals 1, x equals what? 2. Oh, when y equals 1, x equals 2. This is straight line, okay? And then when y equals 2, how about x? When y equals 2, x equals 4. Oh, perfect. It's a straight line. You see that? It's a region bounded by a curve. X equals y squared, and also x equals what? 2y. So that's good, everybody? We're going to rotate this thing about what? Which axis? Y-axis. Let's see what we can get. It's symmetric, right? Symmetric, so we got yes, go. Like this, right? Alright. And then how about when y equals any y, okay? Okay, so for this case, our y value, okay, when we look at the solid vertically, our y value varies from 0 to what? To 0. What is the coordinate for this point? This is when y equals 2, right? When y equals 2. So the solid is bounded between y equals 0 to 2, right? Okay, so later volume y equals from 0 to 2 dy, okay, dy. We need to find a of y. So what is a of y this time? So for example, if we have any y between 0 and 2, when we are cutting this solid horizontally, okay, by a knife, okay, what should we have then? Can you tell? Can you see?
A washer.
Yes, we're going to have a washer, okay? We're going to have a washer with a inner radius and outer radius. Okay. Every time when I draw the picture, it doesn't look very well. So we have a inner radius and outer radius. This is our two circles. Okay, doesn't. Here, this is center. So we have a washer. Yes. Our intersection is a washer. So we need to find the outer radius and the inner radius. So how about the outer radius? The outer radius is when we have to use the outer streamline, right? This streamline, the outer one, right? So when y equals y, what is coding for this point? When y equals y, x equals what? 2y, right? So 2y will be what? The outer radius, okay? Outer radius is 2y. Outer radius is 2y. How about the inner radius? Inner radius will cut what? Well, see this, right? See this. So the coding for this point is when y equals y, x equals what? What is the equivalent for this inner curve? Y square. So y square is inner radius. Outer radius is what? 2y, right? Because that's when x equals 2y, okay? So every y we have, x will be double of the y. The inner curve is with every y we have, x will be what? Square of the y, right? So outer radius is 2y, inner radius is y squared. Alright, so we're going to have our washer, okay, so equals pi times outer radius square, which is 2y, parenthesis square, minus y, pi times what? Inner radius, which is what? Y square. Square. Okay, so that gave us what? Pi times by, okay, I pull this pi out, okay? This is 4y squared, right? Minus what? Y to the 4th power, right? Alright, so we're going to put this a of y back into the formula. This is pi times by 4y squared minus what? Y to the 4th dy. Right? Alright, let's integrate that. Okay, so this is going to be equals pi times by, what is antiderivative for this? 4 third y to the cube minus 1/5 y to the 5th, right? Divided from 0 to what? 2, right? 2. And then that will give us pi times by 4 third 2 cube minus 1/5 2 to the 5th, okay? And then minus by what? When y equals 0, they're always 0, right? So we're going to have pi times by, what is 2 to the cube? 8, right? 4 times 8 is 32, divided by 3. 2 to the 5th, 32, divided by 5, okay? So 32 is 32, it's 32 pi, times by 1/3 minus 1/5. That's going to be 32 pi times our what? 15, yeah, 5 over 15, 3 over 15. That's going to be pi over 15, right? 2 over 15. 2 times by 32 pi, 64 pi out of what? 15. Do you get the same answer? Okay. So, I will, of course, test you in your final exam about this type of the question. Okay.